This video involves exercise 11b, problems involving the binomial distribution from multiple probabilities. So far we've been dealing with binomial distributions, looking at probabilities of single values. It's a probability of 3 or probability of 5, etc. Now we look at situations where we're looking at multiple probabilities. So the probability of x being greater than 3 or less than 4, as we can see here. So let's have a look. We've got a probability distribution here. X values of 0 through to 5 and the probabilities there to 4 decimal places of each of those occurring. Now, there's two ways of going about this. We've got two questions here. If we wanted to find out the probability of x being greater than 3, so that one there, what we could do is add those two figures there together. So the 0.0112 plus 0.0048. If we add those together, do it the old-fashioned way here, there's our answer, 0.0160. Okay, we can do that quite easily. Notice how it's greater than 3, not greater than equal to 3. So that's why I've only included those two probabilities here and here, because it doesn't include 3. The next one, the probability of x being less than or equal to 4. To work that one out, I'd have to work out, add together the probabilities of 0, 1, 2, 3 and 4 together. Okay, and sum them together. And that would give me the probability of x is less than or equal to 4. Notice this time I'm including 4 because of the less than and equal to situation. Now you can imagine, that's quite time consuming to do that in that situation. So there is an easier way to do these multiple probabilities. And we can use our calculator function to work them out. So here's another question. Find the probability of x is greater than or equal to 3 if x is a binomial distribution with a probability of success p, the number of trials n given by p equals 0.3, n equals 5. So the probability of success is 0.3, probability of the number of trials is 5. Okay. So what we could do here, we could do it the long way. So to do that, we'd have to find out the probability of x equaling 3, probability of x equaling 4, probability of x equaling 5, and add them together to get our total. We could do that. We could do our binomial PDF calculations on the calculator, or we could do it using the binomial distribution formula as well. But there is a quicker way. And let's have a look at the inputs that we'd put in our calculator if we're going to do this sort of thing. Should have pointed out a minute ago too, it's good when we're doing these questions to just write down our notation. I mentioned that when you're dealing with binomial distribution, x is binomial distributed, and you've got your number of trials and your probability. So here, in starting this question, we could put down that there's 5 trials and the probability of success is 0.3. That just shows people looking at this question that we've understood that it's binomially distributed, and we just set it out nicely. So if I was answering this question, I'd put that notation down first. Go back to the question. I mentioned that we're looking for the probability of x being greater than or equal to 3, so that's 3, 4, or 5, given that there's 5 trials. So what we do is to get the screen here. Now, we've already used binomial PDF when we're after a single event there, probability of x equaling 3 or 4 or 5. In fact, we could use that here and add the 3 together, but there's a quicker way. The calculator function, binomial CDF, is one we want here. So we'll go to menu, let's write this down. So menu, same sort of path as before, 5 for probability, 5 for distributions, and grab a calculator at the moment if you've got one, so you can see what's going on. And then in the list of distributions, just that choice E there, or you can scroll down and select it, we get binomial CDF. Okay, so menu 55E from the calculator function. We put in the number of trials, which of course is 5. So put that in. We then put in the probability of success, which is 0.3. Put in our lower bound. Okay, so we're looking at 3, 4 and 5. So our lower bound will be 3. Ignore that 0 there. Our upper bound will be 5. Press OK, and we get our probability, if we've done this correctly, which I'm sure we have, as 0.16308. If we're going to 4 decimal places, 0.1631. So that's how to use binomial CDF. That's an introduction to it. Let's have a look at another question now. A bag contains 4 red and 3 blue marbles. I've missed out the first sentence here. She selects a marble at random and then replaces it. She does this 7 times. Find the probability correct to 4 decimal places that at least 5 marbles are red. 3 greater than 3 are red, no more than 2 are red. This is a good one because you need to come to terms with these little phrases here. At least, greater than, no more than. Okay, they sound pretty easy when you read them in English, but converting to mathematical concepts, sometimes you can get a little bit confused. So let's have a look at this. We'll start with the first one. Alright, so number of trials is going to be 7. Oops, sorry. Number of trials here is 7. N equals 7. There's 7 marbles, and 4 of them are red and 3 of them are blue. So probability of success here, because we're dealing with red marbles, is going to be 4 in 7, because 4 out of the 7, if I put my hand in the bag, there's a 4 in 7 chance I'm going to pick out a red marble. So once again we can use our notation. X, normally distributed, 7 trials, probability of success 4 on 7. Alright, so at least 5 marbles are red. Okay, so that will mean, so if I just equate this now to phrasing it in a question, it's going to be X is greater than or equal to 5. Okay, so in other words, a probability of 5 marbles, 6 marbles or 7 marbles being red, because remember there's 7 trials. So we've got 7 trials, as I said. Our probability of success we can put in as a fraction is 4 on 7. Our lower bound is 5. Our upper bound is 7. Okay, because we're after 5, 6 or 7. So let's repeat that. So we're after these 3 results added together. X equaling 5. Probability X equaling 6. Plus the probability of X equaling 7. So our lowest one there is 5 and our highest one is 7. Press OK, and the figure we get to 4 decimal places is 0.3593. So there's our answer. Probability of X being greater than or equal to 5 is 0.3593. On to the next question now. Just put down our data again. There it is. Second question is greater than 3 are red. Okay, greater than 3 are red. So it doesn't include 3. So what we're after here is, this is question B, probability of X being greater than 3. Excuse my dishwasher there in the background. Okay, so greater than 3 will mean 4 through to 7. So number of trials is 7. Probability of success is 4 on 7. The lower bound is 4, upper bound is 7. So if we put that, press OK, then and select OK, we get 0.6531. So there's our answer there. Last question. We've got no more than 2 are red. Okay, so get our minds around no more than 2. So it can be 2, it can be 1, or it can be 0. That means no more than 2. So what we're after here is the probability of x being less than or equal to 2. That covers the no more than 2 are read statement there. So in other words, we're looking at probability of 0, probability of 1, and probability of 2 added together. So the number of trials is 7. Probability of success is 4 on 7. Lower bound is 0. Upper bound is 2. You mustn't forget 0. There can be no red marbles, remember. Press OK. Probability 0.1266. So there we go. That's our first set of questions there. Our second set of questions there using binomial CDF. CDF, by the way, the C stands for cumulative. Alrighty. X follows a binomial distribution with n equals 9 and p equals 0.4. This is another example. Find correct to 4 decimal places the probability of x being greater than or equal to 7. So we've got 9 trials. Our probability of success is 0.4. It's greater than or equal to 7, so we include 7. And the upper bound, there's only 9 trials, so 9 out of 9 is the highest we could get there. Okay, and if we put those in, we get the answer of 0.0250. Next question. Next question. 70% of all trains through Westburn Station arrive on time. If 10 trains go through the station every day, find correct to 4 decimal places the probability that at least 8 trains are on time. Well, let's look at that one first of all. So, key things to look at here are the 70%. Right, so that means that the chance of the trains arriving on time are converted to a decimal at 0.7. 10 trains go through the station every day, so 10 trains there. That will be our sample size. Okay, so that's our probability. Oops. That's our probability. Our sample size is 10. Find the probability that at least 8 trains are on time. So it means we're looking for 8, 9 or 10 trains being on time. Okay, so it's probability x being greater than or equal to 8. That's what we're after there. Let's look at our notation once again. X is binomially distributed. Trials, 10 trials, 10 trains, and the probability is 0.7 of success. Right, so once again, as I've said in these questions, we could work out individually the probability of 8, 9 and 10 trains being on time and add them together. But it's much simpler to use our binomial CDF with 10 trials. Probability of success 0.7. Lower bound is 8. Upper bound is 10. And if we use that, our probability is going to be 0.3828. Just a reminder to get to that screen, it's menu 5, 5 and then selection E or binomial CDF. Right, we'll move on now to the second part of the question, but just copy this over here because we're going to have to use that first answer in this next part of the question. So we'll just put that there. The probability that at least 8 trains are on time for 9 out of the next 10 days. Okay, for 9 out of the next 10 days. Now, what we do in these situations, we've got 2 binomial distributions going on. All right. The first one was to look at the chances of 8 or more trains being on time, but now it's the chance of 8 trains being on time 9 out of the next 10 days. So it's a new variable. We'll call it x again. Okay, it's binomially distributed. The number of trials this time is 10 days, so it can get a little bit confusing, I know, but now we're now shifting to days, so that's what we're looking at there. And the probability of success, that is, there being 8 trains on time, is the probability we just worked out, 0.3828. Hence, if we look here, we're looking at the number of trials. So looking at the number of trains being on time, 9 out of the next 10 days, so the probability x equals 9 is what we're after. 9 out of the next 10 days. Now, because we're only after a single value here, not multiple probabilities, we can once again use Binomial PDF. And you'll notice over here, I've already prepared that screen. Get there the same way, menu 5, choice D. Number of trials is 10. Probability of success, 0.3828. The X value is 9. And if we put that into our calculator, we get the answer of 0.0011. So there we go. That's a more complex example of multiple probabilities. Having seen this, hopefully you can go on and look at exercise 11B on page 530 or 529 to 531.